Welcome to day 4 of EIFL Open Science Trainer Bootcamp. Today we'll talk about different elements of open science. And I called my presentation how to talk about open science and make research more open. Some parts will cover training, some parts will just include conversations or discussions about open science, because maybe you don't have a lot of space yet to actually run trainings about open science, but I'm sure you can talk about open science. So I hope some ideas would be useful for you, and I also hope we will have a discussion how you approaching this topic. Let's start with definitions. What is open science? And I really like a definition from UNESCO recommendation on open science, because it stresses the benefits that open science is about making knowledge openly available, accessible, reusable for everyone. And this everyone includes really everyone beyond traditional scientific community. It's about increasing opportunities for collaborations. It's about information sharing, which really benefits science and society. So open science is not the goal. The goal is better science and better societies, and then it includes traditional knowledge holders and ensures that their input is respected and treated properly. There are also a number of clauses in UNESCO recommendation on open science on ensuring that open science doesn't disadvantage anyone, and unethical practices, like we discussed earlier today, should be prevented. So this extraction of knowledge from knowledge holders or unethical research sharing or publishing practices shouldn't be happening. And open science is a very broad area, so I'll highlight some of the elements, and there might be many more elements that you can include in your presentation. And like Albert was saying yesterday, that don't cover everything about research data management at one session. I think open science is like that. Maybe try to have a number of smaller conversations specific to different topics. I would like to start with one story, which is about reproducibility. When I was preparing my slides, I read this article that said that combining a series of methods for boosting research reproducibility found to produce huge gains in overall success. So maybe if we step back, what is reproducibility? It's basically a major principle in doing research, maybe not in all areas, but in many disciplines. And it's about reproducing results obtained by an experiment or an observational study or statistical analysis. And when a high degree of reliability is achieved when a study is replicated, then it confirms the result. So it's really about strengthening science. And unfortunately, we live in this reproducibility crisis. This percentage of research results which is reproducible is very low. I've seen different numbers. I think the highest I saw was 50%. So half of the results are not reproducible. And there might be some issues with the methods, how this reproducibility happens, or maybe the results are not really the right results to build on, and for sure they're not the right results to build on, because you can't replicate them. So it's like half of research maybe not so good. But what the study said, that they found that if you start in the right way, then you can achieve, I think here it was 85% reproducibility, which is a lot, which is amazing. So this journal article is really about this research published in Nature Human Behavior, and how to achieve high replicability of newly discovered social behavioral findings. And again, it focuses on social sciences and psychology, but I think these results are very, very reassuring, and they describe how workflows could be organized in a lab to achieve high reproducibility. So one of success factors that they mention in this article is pre-registration, requirements for researchers to pre-register their work, which is like a public declaration, what kind of research they are doing, what kind of answers they want to answer with this research, and how they plan to deal with unexpected outcomes that might appear randomly in data. So that's the first topic that I would like to discuss today, pre-registration. PLOS describes it as practice of formally depositing a study design in the repository. And then if you want, you can also submit it for peer review in a journal. And then when it's published, it could be published as a registered report. If you deposit your description of a study, then it increases research integrity, because you demonstrate that you use high standards in your research, and then you help others who at some point would like to reproduce your research results. So it's really about telling other people about the research that you are doing and demonstrating that you are doing it according to high standards. So it demonstrates credibility of your research. It helps with further reproducibility, because you provide information about your study design. And then if you post it publicly, then you can get feedback publicly, and it could be informal feedback from colleagues, or it could be formal feedback if you decide to also publish it in a journal. So it's a peer review of your approach to doing research. Then PLOS is also saying that if you already publish your registered reports in a journal, then it increases your chances for publications of your findings, because then other journals, or same journal, if you want to publish in the same journal, they would already know that they would already know you as an author, and they would already peer review your research approach. It also helps to have more complete research record, scientific records, and there are really a number of benefits for you and also for other researchers. And on this plus page, they end this information page with this question. Do you think pre-registration could help to improve reproducibility in your field? My field is social sciences, so I would say yes. Maybe researchers from other fields would say sometimes or no. So maybe at some point, PLOS will also make this is a result of this survey open. If you want to pre-register your research, I think Open Science Framework is the best place to pre-register, because they really have a very good free tool, free repository for pre-registered studies. There is a URL on my slide, and they also stress that when you pre-register your study, it allows you to stake your claim for your ideas earlier. So if you start working on a topic, if you announce that you're working on this topic, then later on no one will be able to steal your results and say that they were the first, because you have like a stamped proof record that you've been working on this. And then there is an interesting collaboration that they have. It's also on this pre-registration page. They say that Center for Open Science partnered with the Global Flourishing Study to make study data open to researchers, journalists, policymakers, and educators, and anyone can access data immediately upon release for specific analysis purposes by submitting a pre-registration research request to Center for Open Science. So they are saying that they will be sharing data from this particular study with those who will tell how they will be reusing this data. So I think that's an interesting example. So maybe it's not really open data, it's shared data which is shared under specific provisions, but I think it's an interesting example. Center for Open Science also has a lot of resources about pre-registration. So if you want to dig deeper, that's a page for you to start with. And they have a very detailed FAQ. I just posted some of the questions, but there are many more there. So it's really, if pre-registration is a new topic for you, that's a good place to go and check for more information. So this is a real study that is going on. Maybe some of you know Tony Roshelauer, who used to work for Open Air. Now he's with TU Graz, and his colleagues are looking at open peer review benefits and issues around open peer review. And this is how they described their ongoing research. So you see a title of their research, you see who of the researchers who are doing this research. You see that it's a meta-analysis, so they're doing a systematic review of published studies about open peer review. There is a short description, and then there is information about study design. So their main research question is, what evidence has been reported in the scientific literature in the period 2017-2022 regarding the uptake and efficacy of 3 key elements of open peer review: open identities, open reports, open participation. They also describe the data collection procedures in this study, and there is also a document, so there is a description, like metadata of their research, and then you can download a document which describes the approach, and then they describe how they deal with measured variables in the research. And I think it's really a good way to keep track of your research, especially if it's a collaborative research. It's a good way, pre-registration is a good way to share with others what your plans are and what your approaches are. And then they edit how they will make results available. So they're saying that results will be compiled into a Google spreadsheet, and then they will write a narrative report summarizing the extractive data. And then those drafts will be regularly discussed. So, for example, I'm really looking forward to seeing the results of this study, and I saw a presentation of some preliminary results, and they are very interesting and encouraging. So for me as someone who is interested in this topic, it's also, this pre-registration is a good way to know what to expect sometime soon. And there are many more pre-registrations like that. So now there are 10,000 pre-registrations on Open Science Framework pre-registration page. So I just selected results from 2023, and they are really on different topics. And how you can pre-register your study, if you want to, you go to pre-registration page on Open Science Framework, you create your account, and then you select which type of registration you would like to create. So I choose pre-registration, then you click create a draft, and then you write the title of your research, description, and then include your, if you want to, you can include your design plan, sampling plan, variables, analysis plan, other elements. And you also select your field of research, and then you save and make it available. And this is where you select a subject. You can also add affiliated institution, and then you can already select a license, how they can use your work, whether you allow other people to reuse what you wrote here or not. So it's really, I think it's simple when you already have your research plan, and I think it's beneficial for you as a researcher. I heard that some universities started requiring pre-registration from their PhD students, because it's also a good way for universities to keep track publicly what their students are doing. So pre-registration is just one element of increasing reproducibility, but there are also many more elements, and I really like this resource, which is called Turing Way, how you can increase reproducibility of your research results. So if you're interested in reproducibility as a topic, please have a look at this resource as well. So pre-registration was just one story that you can pick and include in your trainings. And I started with it because, like I said, when I was preparing my slides, I read this encouraging article that it's possible to increase reproducibility with pre-registration. But if we talk to early career researchers, especially early career researchers, but I guess any researcher, then all this varies around of doing open science. So if it's an early career researcher, they might be worried what their advisor would think about this, whether advisor would approve or not. Researchers are also afraid that if they start sharing a lot early, then novelty will be lost. And when they would submit a paper to a journal would say, oh, no, we won't publish you because it's not new. You've been already sharing it. And there were no evidence so far yet that it really makes it harder to publish research, that open science makes it harder to publish research. So that worry is maybe not so much grounded in real life results. But then this question, what if I get it wrong? I think that's a valid question because there are so many elements in open science, and some things are quite straightforward. I think what I showed you with pre-registration, it's really hard to do something wrong here because it's simple workflow. But with other elements of open science, they are more complex. And that's why I think it's important to start building students and researchers' confidence in open science as early as possible, so that they would know that it's complex, but it's not a deadly mistake if they make a mistake, and there are actually no mistakes on this process. So I think your open science training should be presenting some tools and opportunities for researchers, especially early career researchers who are willing to try new things, of course, with support from their advisors and supervisors. And if when I do trainings about open science, if I don't have a story to start with, then sometimes I start with research workflow, and I base my presentation on this article, how students could make the research more open, and different elements described on this graph. We already talked about open access to publications. We talked about research data management and sharing, and I'll address some more issues. So one of them is simply creating a space for conversations around open science, and this space could be in your digital literacy training courses, or this space could be in your library. So you can announce, I don't know, a tea hour or coffee hour where students and researchers could come and talk about reproducibility, for example, or open science. And there is this initiative which is called reproducible tea. It's reproducibility, but they are playing with this word tea, like tea, drinking tea. And it's a movement that includes many universities. So they have groups of people who get together and discuss issues around open science and reproducibility. And you can see in which countries there are these groups. And the good news is that most of these events are online as well. And for example, that's a calendar of events for November. And these local reproducibility groups, they're happy if people from other places join as well. So if you would like to start this kind of conversations in your library, then maybe join one of ongoing events and see how others are doing. And I mentioned the library because more and more libraries offer spaces for these discussions around reproducibility. So for example, this is in the University of Oslo. This person, Agata Bohinska, she's a senior academic librarian, and she runs Norwegian reproducibility network. So you see among her tasks as a librarian, she teaches and helps to implement open science and reproducibility practices. She teaches research data management and data sharing. She's supporting digital research skills development. Then she helps with coding carpentries. She co-organizes open science lunches for researchers and students, reproducibility in her university. And then she's a member of a national reproducibility network. So that's yes, open science and reproducibility is a new role for librarians, and I think it would be an interesting role for those who have a degree, because she has a PhD in psychology, I think. So she's a researcher, and then she became a librarian. And Reproducibility Network is another international initiative. So there is Reproducibility Tea, where you can get some ideas, and then there is an international, there are national reproducibility networks, which together create this international reproducibility network. And for those of you who are joining from Africa, African Reproducibility Network, like Continental Network, will be launched next week. So there is this webinar where representatives of UK Reproducibility Network, because they were the first to start this movement, and also African coordinator will share the activities and plans. And if you are from Africa and if you're interested in these topics, I think you should join this webinar. Another way of explaining open science is explain it in the context of project workflows, because everyone is working on the projects, from librarians to students, because they might have some small research projects, to researchers, and when you start working on the project, then you really need to think how to organize your folder structure, how to name your documents, how to deal with different versions of your research, where to get cloud storage. We talked about this yesterday. Decide who has access to project materials and when, during the project, after the project, and all these questions are part of thinking about open science. And I like this slide from UK Data Archive, where they use, they show research data life cycle, but it could be a life cycle of any research. And the point of showing this life cycle in today's context is to give this tip, which our colleague from dance, Marianne, uses a lot. When you think about organizing your project materials, try to think from a reuser perspective. If someone would like to reuse your results, what would be the best structure for them? How would you structure your folders? How would you call your files? And for me, it's really a good way to organize myself, because maybe now I remember why I chose this particular order for keeping my things together. But then maybe in 5 years' time, if I want to go back and see what I did, maybe I wouldn't remember. So this reuser perspective is really good, because you can be a reuser in the future. And it's also about having meaningful file names, making sure that those file names are consistent, and trying to do it immediately, because honestly, I was downloading from Zoom attendance list for the bootcamp, and I did it 3 times, and I think my all 3 files are not called in the same way. So sometimes I start with EIFL bootcamp day 1, then next day I start day 2 EIFL bootcamp, and I keep thinking, okay, on Friday I'll organize that better, and I'll call all my files in the same way. But it's really better to start doing it already when you are doing it, not to postpone until Friday. And Open Science Framework also has a space where you can keep all your project documents. So this is an article I was quoting about easing into open science, a guide for graduate students and their advisors. And this is a place where they keep all the materials for writing this article. So that's how this Open Science Framework space looks like. We used Open Science Framework for the first in-person EIFL Open Science Train the Trainer bootcamp, but now we have Open Plater, we have Moodle, so we don't really need additional space. But if you don't have Moodle, then maybe you can use Open Science Framework for keeping your materials, and you can decide whether they are openly available or whether they only are available for your collaborators or just for you. Then another element of Open Science is a registered report, and it's basically a pre-registration which goes through independent peer review. And it's before you start collecting and analyzing data. It's where you design your study and then share your research design. And there is a list of over 300 journals that publish registered reports as either regular types of articles they publish. Yeah, maybe article is not the right word. Regular type of output they publish, or they might have some special issues where they publish those registered reports. And for an article type to qualify as a registered report, this registered report should go through peer review. And then after this peer review, research results, or not research, this pre-registration registered report is published as an article. The last topic I would like to cover before we start talking about your experiences is a preprint, and preprint is a completed manuscript of potential article is what you as a researcher finished writing and want to publish as an article, and you make it available before peer review, and you usually make it available on a preprint server, which is journal independent, but there are also many preprint servers which are run by publishers, and then in some cases a preprint could appear on a publisher maintained preprint platform and then published in a journal if it's accepted for publication. So with preprints, it's a little bit like with preregistration. It's your priority claim, because you tell everyone when you make your preprint available, you tell everyone that you was the one who completed this research. It also increases citations. So there were some studies that showed that there is a citation increase. And in some areas, for example, in high energy physics, where they have archive for many years, for over 20 years, it's very common to cite papers from archive even before they are published in a journal, because researchers in high energy physics and also other areas that use archive, they can't wait for years until an article is published. But of course, a citation is to a preprint with an indication that it's not a peer-reviewed result yet. It's also an opportunity to receive early feedback on your research and maybe improve your text. And it's a proof of productivity, because we all have very tight deadlines. We have to report about our research activities, and we could do a lot. Like we could write an article, and then it's not really our fault that this article hasn't been published yet, that it takes a lot of time to review and publish this article. So it's almost like a journal publisher fault, but then researchers are suffering because they can't show what they did. But if they make a preprint available, then they can include a preprint in their end of the year report, and they can say, as a researcher, I really completed my work, and now I'm waiting for a journal to publish it. And why preprints are so popular now is because now this time between submitting an article and publishing an article is longest ever. You would think that with all technological advances, it's faster, but it's not. It's really takes a lot of time. And I heard from one journal editor that sometimes they have to ask 100 reviewers until one of them agrees to review a paper. So it's also, there are a lot of papers being published now. There is a lot of pressure on reviewers, and we all know that we don't have a lot of free time. So it's unfortunately, this publishing process is very long now. And also with COVID, there was a lot of push from funders and from institutions to release early findings as soon as possible. And I think the results that we have, tests, vaccines, are because research results were really shared early as preprints, and other people could build on them. There were some fears when preprint started that other researchers would steal preprints and publish their own papers, but most of preprint sources didn't report any scooping problems. There were also fears that journals would reject articles submitted if they were made available as preprints, but it hasn't been, it didn't happen yet. And of course, you should check your journal policy, but I think in many cases, journals allow making submitted versions as preprints, but you have to mention that when you submit your article. But then, of course, if you make your preprint publicly available, then anonymous review won't be possible, because I think then reviewers will be able to see that who you are when they will be reviewing your papers. They will see who an author is. And then there was also an interesting study for preprints in biology, that 2/3 of preprints that were made available on preprint server by archive appeared in a journal within 2 years, and the content didn't really change much. And also a number of journals use preprints as initial step of submitting a manuscript. Milica mentioned overlay journals, where you, for example, there are journals where you submit your preprint on archive or another preprint server, and then they take it from there and organize peer review. And I'm using a lot materials from ASAP so they really have a very good information center about preprints, and they have a lot of useful resources. But of course, it's important when preprints are shared, it's important to disclose that this research hasn't undergone peer review yet. There might be some limitations in this work, and it's especially important for journalists, because sometimes journalists jump into some early research fundings and present them as final confirmed results. So it's important to put those disclaimers that these are your results, you're comfortable sharing them, but they don't have this stamp of quality from other researchers, from reviewers, or from a journal yet. And this is a story about a mathematician from my country, Ukraine, Marina Vyazovska. She got Fields Medal last year. And Fields Medal in mathematics is like Nobel Prize in other research areas, and she was only a second woman who ever got this medal in mathematics, and she got this medal for the research which she published, which she made available as a preprint on archive, and it was such a groundbreaking research that other mathematicians started citing it second day. Like, she posted it on archive, and then starting from the next day, other mathematicians started citing her. And then it took her a year to publish this preprint in a journal. So she published in the Annals of Mathematics, which is like top journal in mathematics. But within 1 year, other mathematicians have already been citing it. So you see that this preprint is available in version 1. Initial version she made available in 2016. And then there is a revised version, which is as of published version in 2017. And ASAP also has many more examples. So, for example, this researcher from University of Pennsylvania says that with preprints, you as a researcher decide when you release your research findings. You're not dependent on journal publishing cycles, and you let other researchers build on your results. That's an interesting example from a researcher from Harvard Medical School. She wrote 2 articles, one that she co-authored as a single author, and then another article that she wrote with other researchers. And she wrote them at the same time, and none of them were published yet, but she wanted to reference her first article that she wrote as a single author in that second article that she wrote as a co-wrote as a co-author. And she made her first article that preprint available, and then she referenced her preprint in that second article. So it was a good way of proper referencing research results. So this researcher from Kansas City University was sharing a story that he made his preprint available, and he was still thinking about a journal, but then a journal actually approached him, because journals are also check-in preprint servers, and a journal invited this researcher to submit this article and publish it in a journal, and it was a very good journal. And then when this article was still undergoing peer review, he received another invitation from another journal, but of course he rejected, because he already had a journal where he was going to publish. But it's also it's a good example that preprint servers are also places where publishers are looking for good content. And then if you are sharing some research results, like in this case, he published an article about a software he developed. People already started using his software when he made a preprint available, and he received citations for the software that he developed, and he also received he applied for a fellowship, and he received a fellowship because he could prove that he's really a good researcher doing useful things. This is a story from a manager from Bill and Melinda Gates Foundation, and she's also a researcher at the University of Washington, and she was saying that when they shared their preprints, they got a lot of useful feedback from other colleagues, and they could improve the text of their article. And this is a story from a postdoc who actually got a job, because a faculty job, because he shared his research results as a preprint, and hiring committee looked at it, and they were really happy with the quality, and he was invited to apply for this position, and he got this position. And there was also an interesting statement from Coalition S, which is a group of funders mainly in Europe, but also there are some funders from Africa, Middle East, North America. And in the statement, they said that when they as funders talk about peer-reviewed publications, for them, peer-reviewed means reviewed by a journal peer review, but it could also be a peer review on preprints platform, because for them, the quality, if it's independent, if it's of high quality, then it's also a preprint which has been reviewed on a preprint platform is also considered a peer-reviewed publication. And to me, this was a very, very encouraging statement. There is a directory of preprint repositories where you can see which preprints exist in which areas. that's a good resource to including in your trainings. And maybe here we can stop, and if you have any questions or any feedback. Thanks a lot for sharing resources.
Hello.
Hello.
Good morning.
Good morning.
Or good day. I'm happy to be here once again. Yeah. In fact, I didn't join early enough, but I hear we are talking about preprints. So which means that preprints are very important. And that if you could have your preprint in the repository, in an open access repository or something, a journal or an editor could, as it were, invite you to publish with them. I want to find out. So is there what is the distinction between the preprint and then the real work?
Preprint is a version of an article or a report that you consider completed. For example, you as an author, you plan to write an article, you write this article, and then you want to submit it to a journal. And a preprint is that version that you are going to submit to a journal, or you might already submit and you're waiting until it undergoes peer review. Yeah. But at the same time, you make it available. So it's a version of your article before peer review.
Peer review, okay.
Mm-hmm. Thank you for your question.
So I heard you were talking about ASAP Bio, and you said ASAP Bio has a lot of preprints. Is that the case?
A lot of materials about okay. Preprints. So it's really an educational resource. Okay. So let me drop a link.
And then please the open. I had open something framework.
Open Science Framework.
Open Science Framework. Yes. Could you, if you don't mind, kindly run by me that particular slide? That particular slide. What actually is the Open Science Framework, and how important is it to a researcher, especially to preprint? Please, did you hear me?
Yes, sir. So I'm okay. Posting in a chat two links to ASAP Bio. So it's an initiative to promote the use of preprints. Okay. And I put a link to a homepage and also to their preprint info center, which is very useful for me because it includes a lot of reusable materials. For Open Science Framework, maybe I'll share my screen. And I'm also dropping a link in a chat. So it's like a shared repository, I would say, like maybe some of you know Zenodo. So it's like that, but it has some specific functionalities there. So you see it's free and open platform to support your research and enable collaboration. And here you can create a space for sharing your project materials. So it's like, I think it's like a collaborative space where you can have where you can share some files, where you can include links to Google Docs. If you use Google Docs for some things, you can have a wiki. So it's like a space, collaborative working space. And on my slide, I'll go back and I'll show that example. Yeah, maybe I'll open it. This is how it looks like as a collaborative working space. I dropped a link in the chat. Screen now. This is how it looks like as a collaborative working space. You have a title, you have 3 people who contributed, date when it was created, it's a project, description what this project is, and then they have some files that they made available, and you can have a look at this wiki files, and so you can use it for organizing your work on a specific project. And then there was one more example of a registered report, and I'll show you how it looks like. So it's another functionality of the same platform where you create registered report. So this is a description of a study, design plan, description of a study design, also information about people who are doing this study. You can download this description as a document. Then they describe their sampling plan, how they are collecting data, what is their sample size, what are variables, and they don't have analysis plan yet. Maybe they will add it later on. Maybe they wouldn't add it, because it's up to you to decide how much information you provide here. And then some other information, how they will make results available. So it was created by using this open science framework, and it's free. It's a free tool that anyone can use.
Okay, my last question: if I found a preprint, I can cite it. I don't need to wait for it to be published before I cite it, isn't it?
You can, but you have to mention that you are citing a preprint.
A preprint, okay.
Yeah, that's okay. You have to tell people that it's not it's not a peer-reviewed article yet. A good thing is that usually on preprint servers, if a preprint is made available, but then later on an article is published, then there is this information added that there is another version of this preprint which is published as a journal article, and then you can decide whether you are still citing a preprint or whether you
preprint or the article. Okay.
Cite an article.
Okay. Thank you so much. Most grateful.
Iryna, I shared an example of an article and a preprint and a pre-registered report where people can see the whole workflow. So there was a registered report and it was later published as a preprint, and then eventually it was published as an article. So you can see, and you can see that each output has its own DOI, and that all these DOIs can be related, because on the where you find register report, you can see the DOI of the final article as well.
Thank you for the information. So grateful.
So you have it in the chat so you can see for yourself.
Okay.
A colleague raised a hand under the next name, admin. Sorry.
Oh.
Good morning. Can you hear me? It's Kalamork from Botswana.
Yes,
I have, it's not a question, but there is, I want to add some points based on my experience about preprint. Researchers sometimes they're depositing their research as a preprint in institutional repository, but later they want to be published that the same research out, the research work for the public, for publisher. They're sending that manuscript to the journal. The main challenge is that sometimes this journal publisher, they have to tracing the plagiarism. So sometimes it will pick that preprint is already on the system. It might be reflect high plagiarism rates when they are checking the plagiarism. Yes, particularly from the institutional repository, yes, sometimes we are withdraw that's what's called the manuscript. But my question is it possible for those, the one you mentioned, some platform putting the preprints to withdraw after the researcher are depositing the research in those platforms? Is it possible to withdraw during the process of publication? Because sometimes it will raise this as a challenge.
Yes, especially with COVID, when there were a lot of speculations whether COVID was generated by humans in a lab, with all these conspiracy theories. There were a number of preprints confirming this conspiracy theories. And a lot of preprint servers introduced a policy that if they have solid evidence that results which are shared are not acceptable as scientific results, that they will be removed. And I managed the COVID-19 collection on Zenodo, and we had one of those preprints posted on Zenodo and included. There were two preprints. One was obvious, which we didn't include in the collection. Another one we included, and because it wasn't that bad, it wasn't that obvious that it was wrong. But then Zenodo specifically developed a policy to remove that bad one, and maybe they exercise this policy maybe 3 or 4 times only, but they did it because it was of that scale, like that bad. But if it's a plagiarized research, then I don't know if there is no review. A preprint server usually doesn't check for plagiarism. So I'm afraid there might be some plagiarized papers.
But I understood the question differently, because if a preprint, so correct me if I'm wrong, so if a preprint is available and a tool that is used for plagiarism tracking is aware, has access to this,
Yes.
then when they do the scanning of a manuscript that is submitted, then it's possible that the potentially plagiarized content that is recognized by the tool may be higher, because the art preprint is available.
Mm.
So basically, I don't think that withdrawing preprints, regular preprints, is a solution to this, because these tools that are used for plagiarism tracking should be used with great care, and it's up to humans to check these results. And if a human who is checking the results, the information about the preprint and the source and the authors is available, it can be checked, then the human who is checking the results provided by the tool should take this into account and should exclude this as plagiarism, because it's legitimate. It's a legitimate preprint. It's a legitimate practice. So it's not, we shouldn't change the open science practices because of the limitations of the tool, but the tool should be used as a tool with great care and with responsibility, and those using the tool should be knowledgeable. The same applies also to some irrelevant results, some irrelevant things that appear in those reports as plagiarism, and they are not really plagiarism. So they should know how to set up the tool and how to evaluate the results provided by the tool.
That's true. Okay.
Thank you.
Thank you.
Emmanuel, did you want to ask a question or provide a comment?
Can you hear me?
Yeah, I was asking Emmanuel because he was trying to speak a couple of times, so maybe just give a minute to Emmanuel if he wants to say something. If not, maybe Dragana, please.
Thank you. Thank you. Well, you can see me, you can hear me, I suppose. Well, I just want to confirm and to say that the comment that Milica gave was, well, quite accurate, and that it is also our experience with plagiarism tools concerning PhD thesis. The fact is that the percentage of plagiarism within these tools is not exists, of course, but it is not relevant for proper evaluation of results. The proper evaluation has to be performed by human, and to so not that quantitative, that number is not enough. It should be evaluated the spots, the parts of the paper which are identified as similar to some other sources. So the fact is that tools for plagiarism will in fact track this path of one paper from preprint to final paper. So it's not in fact it helps to identify this path, to track this path of one paper, and not to identify this percentage as plagiarism. No, these tools for plagiarism has different roles, in fact, not only to give the percentage, but to identify sources.
Thank you so much.
Thank you so much. Thank you.
And Gift was asking difference between preprint and publishing. So a preprint is a version that you consider final as an article author, and you make it available on a preprint server, but it hasn't undergone peer review yet. And then when you submit this article to a journal, then it goes through peer review. You change your text based on feedback from reviewers, and then you publish it as an article. There are some preprint servers that do peer review as well, and then you might change a version of that preprint based on feedback from reviewers on preprint servers, and then you can make a second version of preprint available. So a preprint is a version that you would like to publish, but it hasn't undergone formal review yet. It doesn't have this quality stamp from a journal or reviewers. I hope it answers your question. Any other questions? No comments? So maybe I will ask Lilia to tell her horror story, because now we're moving into horror and hooray stories, and I think this story is a little bit related to the discussions that we're having in the chat about stealing. What is stealing, and when who and when could steal?
Just a
So what
second,
do you
I
think?
was without my earrings and listening just to two speakers. I think it's better sound like this. I heard a story this morning, and it's not, unfortunately, the first time that I hear a story of this kind, about a young researcher who came into an institution, and he was engaged in some research, very much engaged. And then in the end, he was given the task to write a paper for a very high-ranked journal. And then he wrote that paper. And then his senior colleagues went through the paper and said, okay, that's it. We will now proceed with the publishing procedure for the journal. And they actually excluded him from the list of authors from that paper. He was so disappointed. He came here yesterday, actually, and he was looking for a job in our institution. So he told us that story that happened a year ago. And at that moment, he got so disappointed in scientific environment that he gave up on his further career, scientific career. And fortunately, he only made a pause, not exactly stopping the career. So after a while, he changed his mind a little bit, but he was very, very disappointed at that moment. We all actually understood this sort of pain, because this is really a terrible thing to happen. And I talked to him a little bit about the new issues regarding the open science, which is actually a complex of ideas that prevents, among other, this sort of behavior of senior colleagues. So Iryna and I were discussing the situation at the beginning of this day, and we were wondering if this is the situation only in, for example, only in Serbia or only in Ukraine, because Iryna had some stories of that kind. We asked Jonathan, and he said that he was familiar with similar but not so radical situations. So I was wondering if any of you had the same experience from the people around you, and is this actually something that happens worldwide, or is it something that happens randomly? I would like to ask all of you participating in this.
And the open science angle of this story is that if that researcher would pre-register his study, if he would make his completed version available as a preprint, maybe other colleagues wouldn't steal so blindly, because then they would know that they are stealing something that is already publicly available with a person's name. Or maybe a journal wouldn't publish this article because they would notice that authors are different. Maybe a journal would already flag that at the submission stage. So,
and he could report, he could report, he could do something like this. He was helpless, completely helpless. And it is a terrible thing to happen to a young person, because it can discourage him from further staying in science, and that is really sad. Because if a young researcher can perform such sorts of research and write a paper almost by himself, he already has something, a big capacity for being in science, and it's a really pity to do such thing to him. So please, if you have some some sort of stories like this, can you please share it with us?
I know many, but I won't share these stories.
Okay, you're Serbian.
No,
you're
I
Serbian.
know
You don't
many,
count.
but I will share an example of a colleague who she wanted to publish a paper, and she was asked to provide data along with the manuscript, and she asked me what to do, whether there was a safe way of providing her data to peer reviewers. And then I said, okay, in case you have several options. One of the options is to go to, if you publish it on Zenodo, then you have to make it public, because the peer reviewer wouldn't be able to see it, because Zenodo doesn't have an option to provide a private link. And you will have to make it public in order to make it available to the reviewer. If you go to Figshare, there is an option that you have a private link, and only those with the link can access the data and have a look at the data before the manuscript is accepted. If you have an institutional repository, which you don't have, I mean, if you had an institutional repository, you could do the same. You could publish the data there and provide a private link. So these are the options that you have. So the option to send the data to the reviewer to submit it via the submission system, that's something that she didn't want. She said it at the beginning. And then she took 24 hours to consider all the options. And then she got back to me and said, I decided to publish the manuscript as a preprint and to publish all the data on Zenodo and to make it public from the outset, because based on the analysis of the options that you presented, I say it's clear to me that it is the best way to protect my work from stealing. So let's talk about good examples.
And I also think this is a good example because Iryna showed that in her presentation that researchers are often worried if they preprint something, it can be stolen from them. Actually, preprinting some researches actually prevents from data being stolen. It is the other way around. That should be very clear.
There was a question about best place to advise researchers to post their preprints on. I think that disciplinary preprint servers are the best because that's where other researchers go. I know that mathematicians, high energy physicists, they start a day with tea or coffee and browsing what's new on arXiv. Similarly for bioRxiv, medRxiv, I would recommend those disciplinary specific platforms for researchers. If you're working in the area of library and information sciences, I don't think, well, there are some specific servers, but they're not as popular as arXiv or bioRxiv. They may be for library and information sciences. Maybe an institutional repository would work, or Zenodo or Open Science Framework. And I don't know if other colleagues have different opinions.
There is a list in the resources for day one. There is a list of there are some additional resources for preprints, and you can find that there a detailed list from AsaBio and also from Wikipedia. So you can go there and have a look what's around, and then you can see who publishes there. And based on, for example, on the number of articles, on the dates, on the frequency of publishing there, you can see whether they are used or not.
The SCORE directory is much more comprehensive now because it was developed, because AsaBio couldn't maintain a list of preprints on their server. So it's not that up to date. a list from core. Put a link in the chat. This directory is much more up to date. I don't know about Wikipedia page. There is a question about handling changes of the article. You just make another version available. So you make version 1 available, and then you produce a second version, revised version based on feedback from reviewers. And then you say on the page where you posted version 1, there is a notice that there is an updated version of this article available, and I'll show these examples after break. So maybe now is a good moment to break for tea or coffee, 20 minutes, and then Dilas, sorry, has a presentation of training experience, so we'll start with that, and then we'll talk about open peer review and free and open source software and some more elements of open science. Well, thanks a lot, and break time now. Our next topic for today is open peer review, which is one of the elements of open science. And traditionally, we know single or double blind peer review when neither an author knows who peer reviewers are, no peer reviewers know who an author is or authors are. But there are other elements of peer review that are becoming more and more common. Open peer review, where there are open identities, where authors and reviewers know who they are, where review results are made openly available. So those reviews are published as open reports. And then there is another element which is called open participation, where anyone can participate in this peer review process. There was an article published last year based on an experiment when a test article was emailed to a number of journals, and one version of the text article was authored by unknown researcher, and then the same version was fakely authored by Nobel Prize laureates. And the result was that when there was a Nobel Prize laureate name on the article, then reviewers treated that article much more favorably than an article of an unknown researcher, although the quality of the article was identical. So that's one of the arguments why open identities are bad, because then people with big names will have preferential treatment in the preview process. But then there was an answer published that of course there are biases, but maybe open peer review could still overcome those biases. And authors of that respond were saying that in some areas, for example, in social science and humanities, because I come from social science and humanities, peer review is not really that much of an abstract objective quality, but it's really a question of consensus or agreement in the community or between a journal, editor, reviewer, author on particular level of quality. So there are disciplines in which review process is a discussion, exchange of viewpoints and opinions, or maybe even a negotiation process, and that's additional reason why this process should be open and transparent. I always use Open Research Europe as an example of publishing platform that practices open peer review, because I have some experience publishing there, and because it's a platform which is supported by the European Commission, which is the largest funder of research in Europe, and they practice this open peer review. So how it works, a researcher who received funding from the European Commission can submit an article to publish on this platform. So they already have some eligibility checks when they award grants, and they believe that if a researcher is good enough to receive a grant from the European Commission research grant, then the researcher should be good enough to be able to publish. They don't charge article processing charges. Publishing is free for researchers. And what you do, you submit your article to this platform. They have different requirements for different types of articles. You follow those requirements, you submit your article. They check whether your article follows their requirements for a journal article or software article or open letter or any other type of output that they publish. Then they check an article for plagiarism. They check for some basic scientific quality. They check whether there is a data statement attached to this article, because they also have a data availability policy, and they check for ethical issues. And after those initial checks, which last for a couple of weeks, and in my experience, when we submitted an article, there were some questions going back and forth from the editor, so they were really looking very carefully on what we submitted. And after that, after we answered all the questions, when this platform is confident that this is a scientific article that deserves to be shared, it is made available on this platform as a preprint. There is a DOI, digital object identifier. It's openly available for viewing, and people can start citing it. And it's also indexed in Google Scholar at the moment when it's made available. And then if it's made available on this publishing platform, it can't be sent to another journal. So it's already made available. And then the peer review process starts, and reviewers see who the authors are. Reviewers' names are also disclosed, and reviewers' reports are made available. And then only versions of articles that pass through peer review are sent for indexing in Scopus or Web of Science. So how it works in practice, Open Research Europe is published by F1000. So they've been known for, they're part of Taylor and Francis, and they've been known for their experience with open peer review, because I believe that open peer review enables this open and transparent conversation. It increases opportunities for collaborations between authors, reviewers, and it reduces biases. And then peer reviewer feedback is provided openly and constructively, and then it really improves the quality of peer review, and it improves the quality of an article. So I'll show, I made the slide yesterday, so you see that there were some papers made available as of 14th of November. So one of them is a software tool article. So it's a simpler version than a research article. It describes a specific piece of software that was developed, and this article is a second version of the article. No, sorry, this is still this one is the first version. So it was submitted as it is, and it is still awaiting peer review. So you can see in the approval status, it says awaiting peer review, so it hasn't been peer reviewed yet. So because I moved the bar, I have to stop sharing and share again. Sorry, this issue with my slides sharing. Another article that was also posted on the 14th of November was actually what was also a software tool article, version 1 awaiting peer review. And then one more was an open letter, and it was already second version. So the first version was submitted in March. 2 people whose names you can see reviewed this article, and one of them approved it. Another one requested amendments. Another reviewer didn't approve. And then authors of this article prepared a second version, and this second version appears as revised version. It describes amendments from version 1, and it's now awaiting feedback from specifically from that reviewer who didn't approve the first version. And you can of course see reviewers' report as well. Then another example is a research article which also exists in its second revised version, because version 1 was submitted in June, and then one reviewer approved it, but then another reviewer approved but requested some changes. And then what was made available in October as second version includes also descriptions of amendments from version 1, and they also provided a detailed response to the reviewer who requested amendments, and this detailed response is available. So here reviewers could see who authors are, authors and everyone else saw reviewers' reports openly. Authors responded openly to the reviewer report, and they produced second amended version of an article. Some journals have mandatory open peer review, like Open Research Europe. Others give options to reviewers. I was asked to review this article in PLOS One, and I was asked whether I want to disclose my identity as reviewer or not. And I decided that I would like to disclose my identity. And then I requested some changes in my review report. And then when this article was published, after the changes, of course, I saw a second version after peer review, and PLOS only publishes final version, so that previous version that I saw as reviewer wasn't publicly available. This final version that was published, that I was happy with, publicly thanked me in the acknowledgements, and for me, it was really, I really thought that it's a kind gesture, because another reviewer also disclosed the name, so both of us were thanked in this acknowledgement section. So that was a short overview of open peer review, and there are still questions around that, but I think it's an initiative was trying. Another open science element is reproducible code and open research software. And usually when I run generic open science sessions, I don't focus too much on that, because it's really a specific topic for specific audiences. And what I usually mention is that there is this fear that you have to be a programmer, a software developer to practice reproducible code, but it's not actually, because there are a lot of applications available now where you can even use Windows-based programs like SPSS that was mentioned earlier, or JSP that could be used in more reproducible way. And there are some tips. For example, if you use SPSS statistics, then you can click analysis options in the window, and then you can agree to certain parameters that are described here on the slide, and then you make your research a little bit more reproducible, and similarly for JSP. And then, of course, there are specific programming languages like Python or MATLAB that you can use in your research analysis. And overall, when I talk about software, I stress that there are benefits around open source versus closed source software in terms of customization. It's quite often there are many more customizable options of open source software than closed source software. If I'm interested in a customized version, it's also free, and it has community of users. I can ask a question, so there are benefits around that, and there is a very good resource, the Turing Way, that I already mentioned, that provides a lot of tips and advice on how to use free and open source software in research and make it more reproducible. Another initiative was highlighted is a software heritage initiative that archives free and open source software and assigns persistent identifiers to software pieces. So that's that's helpful for preserving software for future generations. And when I was preparing my slides, I also found this article in Quantitative Science Studies that says that retracted articles use less free and open source software and cite free and open source software worse. So there are some elements of quality. So usually people who work with free and open source software know how to cite it appropriately, and usually the reasons why they use free and open source software, apart from costs and other reasons, they use it because it helps to produce more reproducible research. So that was an interesting piece of evidence that I found. And also, when I was preparing my talk, I saw an interview with Alexandra Freeman, who is a founder of Octopus publishing platform, which Milica also mentioned in her talk. Octopus is a publishing platform that is funded by research funders in the UK, supported by GISC, which is UK Research and Education Network. And it's a platform that allows researchers to publish in smaller units. So instead of spending a lot of time writing a full journal article, they allow researchers to break their findings in smaller pieces, and they can publish idea like pre-registration or data set or just analysis before they have this final article. So it's really a platform for publishing free, because they don't charge any article processing charges, fast and fair, where researchers could share their research results. They launched recently, and they already have, I think, 5,500 types of outputs published. So really, researchers are using it. But unfortunately, these types of publications are not yet considered as proofs of research productivity by many institutions. So it's an additional publishing platform for researchers, but many of them are not promoted based on what they share on Octopus, because they are still being promoted on publishing journal articles in journals that are indexed in Scopus or Web of Science. And Octopus founder was saying that, unfortunately, current research evaluation system discourages this kind of new best practices of sharing research results. And it's really up to funders or institutions to make this change happen, because it's still an innovative publishing approach. So it can really change the research culture. It can help advance science, but it's really up to institutions and funders to support these kind of approaches. A good news is that in Europe, there is a coalition for advancing research assessment, where new members are joining almost on a daily basis. And those members are universities, funders, and together they are working on changing their approaches to research assessment, making it more equitable, really focusing on the quality of an output and not a journal brand. And it started in Europe, but it also has members from all over the world. And there is a similar initiative, well, maybe not a similar, but like-minded initiative in the US, which is called Helios, where large universities participate. So there is a hope that at least in Europe and in Americas, there will be changes in research assessment. There are also discussions in Latin America, and it would be really great if institutions and funders from Africa and Asia also follow these discussions and think about their continental initiatives to change research assessment. And I think we already mentioned European Commission and Horizon Europe when we talked about research data management, that if a researcher receives funding from Horizon Europe, which is a research funding program for European researchers, then they have to adhere to mandatory open science practices. So they have to provide open access to journal articles via repositories, immediate open access under Creative Commons attribution license. They have to manage their data fair. They have to produce data management plans. They have to follow as open as possible, as close as necessary principle for sharing research data. And if they can't share data, they have to explain why they can't share. They also have to make information about research outputs, tools, instruments needed to validate research results. And then they have to provide digital or physical access to results needed to validate results presented in scientific publications. So these are mandatory practices for all European researchers required by a funder. And then they also have a set of recommended practices, for example, involving citizens, civil society, in research agenda, practice in citizen science, early and open sharing of research. So for them, pre-registration and registered reports are not required, but optional, and it's a part of good recommended practice. Then they also recommend research output management beyond publication and research data, measures to ensure reproducibility of research results, provide access, open access to research outputs beyond publications and data, software, models, algorithms, workflows, and participation in open peer review is part of recommended open science practice for European researchers. And it's a recommendation from a funder. I didn't really talk a lot about citizen science because we don't have time, and I don't have much experience with that. I helped to write some guides how libraries could help citizen science projects. Those guides were released by LIBER, European Library Association. But maybe some of you on this call, and I know that some of you have much more experience with citizen science, so maybe you would like to share that. And that's once again a quote from this Octopus funder, Alexandra Freeman, who is saying that what kind of future she sees for scholarly publishing. And she's saying that it's really moving beyond PDFs, words, graphs, and thinking about other ways of sharing research, which are more reproducible and which are more available and which are really available much faster than journal articles nowadays. And to address that first fear that I mentioned in the beginning of my talk, that open science is really a lot of pain with little gain, but it's not true. Of course, there are a lot of elements of open science, but some of them could be practiced maybe immediately. About some of them, your researchers whom you train could think about. And it's really a lot of open science practices are just good science practices, and in the long term, they will help researchers as well, but they also helping researchers already in the short term. And again, thinking about career opportunities, I see a lot of job announcements for early career researchers that mention open science experience. So it's really type of experience that is appreciated by universities now, and I think it's also a good thing for your career. And similarly for librarians, more and more job announcements include this requirement to understand open science. So a short summary, that I usually use when I talk to researchers or students about practicing open science, some steps that they can make. They could deposit a preprint, publish papers in open access, share data, especially data which are mentioned there in journal articles, share codes, tell other researchers and students about open science, and also help develop and implement open science policies in their institutions. And you can talk to any researcher, or you can focus on some topics, and EIFL with Creative Commons and Spark are now focusing on climate, because unfortunately, majority of climate publications are not open, and it's not helping in solving climate change crisis. So we have this campaign to open up climate research, and if you want to start practicing open science with your researchers, and if you want to start with climate change and biodiversity departments, then we could collaborate with you on that. And then there are many benefits in open science, such as greater collaborations, greater transparency, higher citation rates, increased visibility, greater efficiencies, greater potential impacts. And it's also something that a lot of funders require already. And I think more and more of them will be requiring if they're not requiring yet. And then when I run these open science trainings, I usually have this kind of questions. So I ask researchers whether they practice some open science elements or not, and then which aspects, and whether they would like to share their experiences, whether there are any practices that they would like to start practicing, and what they need to do so. Maybe they need more trainings, or maybe some other elements. And a good way to structure this kind of discussions are open science communities. And these are informal groups of people. Like I mentioned, reproducibility communities. There are similar open science communities now in 16 countries, some of them national, some of them institutional. In Serbia, there is one on the national level, and I hope our Serbian colleagues will share their experiences. But it's a network that supports each other. And if you're thinking about starting a community, open science community in your institution or in your country, I think that's a good network to connect to. And that's all I wanted to share on open science. And I'll be happy to answer any questions you have or hear your thoughts, how you talk about open science. And I see that Dailas joined, and maybe Dailas could share presentation now. So let's maybe I'm scrolling. Let's maybe start with questions, if there are any questions about my talk, or if someone would like to share. And then if not, maybe Dailas could share presentation, and then maybe Serbian colleagues could talk about their open science community. I think that would be interesting. And
Hello?
Dailas, please tell me, do you want your presentation recorded or not? Because I can keep recording or I can stop recording. So tell me what
at the moment, I think at the moment you can stop recording.
Okay, I'll stop my
Okay,
recording.
thank you.
Hello?
I have a short presentation on how to make your training materials fair, findable, accessible, interoperable, reusable, and these discussions about fair training materials started by a group of trainers from life sciences. You see some of their names, and they published a paper which they called 10 Simple Rules for Making Training Materials Fair, where they suggested sharing training materials, properly describing them, defining learning outcomes, make these materials reusable, usable and reusable for trainers and trainees, encouraging contributions, finding ways of keeping those materials up to date if they are shared. And they provided some initial tips. So, for example, there are some pros and cons around certain file formats. For example, PPTs and PPTX are easy to be reused, but you don't have version control and they might not display properly if you don't have Microsoft tools. And then with PDFs, they can be displayed identically in any environment. And even on mobile phones, it's easier to have a look at PDFs and PPT. But then they are not easily editable and they also not version controlled. So there are pros and cons around different file formats. And it's really up to trainers to decide which approach they take. And then there were some recommendations, what should be included, like keywords for training materials, clear reuse license, author names, contact details, learning outcomes, very important target audience, structure duration, any additional information that would be useful to other trainers. And then later on, this group of people, with the help of some others, prepared a resource which they called Fair Training Handbook, and it's a short resource for trainers. Why make your training materials fair? How to choose appropriate types of materials and formats that would facilitate fairness, how to create them for easier reuse, which metadata to use to describe them, why persistent identifiers are important for sharing materials, how to make materials accessible, reusable, provide licensing, how to boost discoverability, and then how to ensure that there is proper recognition, acknowledgement, and authorship in training materials that are shared and also materials that are reused. And if you're interested in this topic, please have a look at this resource. It's really, it's short and provides some useful tips. There are also some useful tips developed by Ferris Fair project. So they created as internal project fact sheets, how to deposit training materials in Zenodo, because they use Zenodo for sharing their research results. So they describe some steps, how to make training materials reusable or findable or interoperable or accessible. And it's very, very detailed. These are very detailed instructions. Research Data Alliance Education and Training Interest Group produced a series of recommendations on the minimal metadata set to help with discovery of learning resources. And this document includes suggestions on using descriptive metadata, like having an abstract, authors, language, keywords, version date, then providing information that helps with access and reuse, URLs, license, and then providing educational information, describing learning outcomes and other useful information that trainers would like. And I think now these recommendations from RDA are like the latest standard in sharing training materials. And what Milica and some other colleagues did this year, we looked at these existing documents and we came up with quality assurance criteria for learning resources. And you can see them on this slide. So if you share your training materials, it's good if you define scope, subject teams, disciplines, domains, keywords, when you define your target audience, when you define your learning outcomes, and if there are some knowledge prerequisites, you state them. Then you mention what kind of qualification or level of training will be obtained when this training is completed, whether there will be any skills, competencies gained after this training. Then what kind of training methods you use, whether it's workshop, lecture, lab, and estimated length of activity. What is a delivery method? In-person training, self-paced course online, online training, etc. And then whether they are in line with FAIR principles. And you can see this principle that they are available on appropriate platform, have enough metadata, persistent identifiers, DOIs, for example, are assigned, or ORCID IDs. Then some instructions are added. For example, if there's a game, there is an instruction document how to play this game. There is a license attached, and copyright and usage conditions are clearly described. And then if there are some technical requirements, and they also included. And then if possible, accessibility approaches are also followed. And then if there is a plan to keep materials up to date, then it's mentioned in the resource. And if there are known translations, that they also included. For example, in our list of games about open science, if there is an English and French version of the game, then we included that information. So in the list of games, you'll see some, well, 2, I think only, but at least two games in French. So that was a short information, and I think it's a recap of FAIR principles, and I think it's also an opportunity for you to think about improving fairness of training materials if you share them openly. Thank you so much. we are out of time today here. If you have any questions, we still have time for some short questions. If not, then we'll wrap up for today. Maybe I can show you where today's materials are. Let me drop a link again. So on the open platter, you see my first presentation, my second, and then there is a link session where there is a UNESCO Open Science Toolkit and 2 glossaries, which I like about Open Science, Forster and Fort. And here I will add some more resources that I referenced in my presentation, like sub-bio, pre-registration, and I'll also add some resources about open innovation that I know about. Thank you very much and see you tomorrow.